have you tried, are you familiar with, for example, maybe the Webpack approach to this, like the Webpack runtime analyzer, or these alternative approaches to some of these ideas?
I'm not familiar with Webpack runtime analyzer. Can you just quickly describe it? What does it do? You don't know?
I personally cannot. But I think the idea
I'm not familiar. So the thing with Webpack is that there are lots of plugins, lots of different options, and it's hard to figure out what are the right ones. And that was the point of my talk. And it's not just Webpack, it's like the whole ecosystem. If you want to be successful in building an application today, you not only need to understand Webpack and all of its plugins and the defaults you need to override and opt into, but you also need to understand the libraries you're using, make sure that you're using the right format of those libraries, whether it's CommonJS or ESM. And then if you have transpiler, TypeScript, Babel, understand how they transpile code, because that can cause problems for Uglify. So you have this whole chain, and anything in that chain can cause problems. We are making sure that this gets better over time, but today you just need to be aware of these things and be able to opt into the right options, which is not fun.
Yeah, that's certainly a fair point. Maybe just best guessing based off of the name. I think a lot of the techniques that you kind of talk about are traditionally focused on the static analysis level, right? So at compilation time, we don't have information about, say, for example, the runtime types or something like that. Have you thought about, for example, using profile guided, taking a profile of how the application runs and then using that in any of these optimizations?
So one thing that we found useful is to look at the coverage report in Chrome and Safari, code coverage. If you bootstrap your application in DevTools, you can check how your code ran and which lines executed. And this can identify chunks of that code that were downloaded but were not needed because we didn't execute them. Often these dead branches are in if statements, and there's not much you can do about it except big refactoring if it's possible. But sometimes it finds big chunks of code that are just functions that are just sitting in the bundle, never execute. And then you can target those and see why are they here, find the retainer, and perform the optimization necessary to remove those.
Is that generally a manual process, or is there some sort of automated tooling that helps out with that?
Right now it's a very manual process, and I'm hoping that as we focus more and more of our attention on solving these kinds of problems, the tooling will get better. Even just analyzing dependency graph today is not trivial, because usually the tools we have, they don't show the right kind of graph, or they get overwhelmed with the amount of data, because often if you just look in the symbol table, it can contain like thousands and hundreds of thousands of symbols for large application. And these tools get overwhelmed. You just see big graph with like lots of nodes and lots of edges between the nodes, and you're like, okay, this looks pretty, but it doesn't tell me anything. So I think the more we work on these problems, we will build tools that will help us visualize this in a better way. I think it's actually very similar to what we went through when analyzing memory leaks, because in a way, the way I'm starting to think about the payload size problem is it's very similar to memory leak issue, but instead of being runtime memory leak, it's like a build time code leak. And the same techniques that we used to debug memory leaks can now be used to debug these code leaks. And I think the same way how we over time build tools to debug and visualize problems with memory leaks, we will do the same thing with these code leaks. That's
quite a useful analogy, I think. It's oftentimes useful if you can think, actually this is a problem that has the same, is congruous with another domain over here. It's very nice to be able to apply those same techniques.
Yeah, and it's a generic thing in software engineering. Like most of the problems we are solving today have been already solved in C, C++, Java, whatever it is. And we're just reinventing the same solutions. And often it's better to just look at how it was solved and copy the solution from there. But the hard part is to find the analogy and realize that, oh, this is the same problem as over there, but over there it was a memory leak, whereas here we're dealing with payload size.
So there's some kind of questions around, say if you had a theoretically ideal tree shaking approach, like you should have no dead code whatsoever, right? What is the challenge in kind of, like as you approach this ideal, what are the challenges in getting to that?
Not breaking shit. Because the more aggressive you get with optimizations, the less confidence you have that you're doing the right thing and you're not breaking things. A good example is Clojure Compiler. So Clojure Compiler is amazing at figuring out which code can be removed, and it does it at a much more granular level than any other tools out there today, because it can actually remove methods that are not called in your application. It can remove properties. It can rewrite the structure of the code in a crazy way. But it only works if you provide sufficient type information, which is very difficult to do in the open source land today. At Google, we have very controlled ecosystem where we have typings for all of the APIs, even the third-party libraries that we use. But most of the software we compile with Clojure Compiler is built at Google. And for those, we have sufficient type information to do this kind of optimization safely. Externally, outside of Google, we don't have this. So this is the biggest challenge for Clojure Compiler and applying the advanced optimizations that are coming from Clojure Compiler in the open source community, because it often just breaks stuff, and it's very frustrating to debug.
Yeah, I'm a huge fan of the Google Clojure Compiler, especially coming from the ClojureScript community. Like it's the things it can do are quite amazing. You talked a little bit about the ability for the Google Clojure Compiler to do all sorts of crazy optimizations. There's a question about why is it able to do these things where Uglify.js, for example, or these other ones are not. Maybe you can tell us like how the type information helps it to be able to do this kind of thing. Like what are the things that, like how does it enable you to make these optimizations?
I'm not an expert on the Clojure Compiler internals, but my understanding is that it uses type information to do all of these optimizations. So if you have a class that you know that has 7 methods, and you see that in your application you use this class in these 3 different sites, and you call only 2 methods, then you can remove the ones that are not used. But to do this safely, you need to know where the call sites are, which you cannot do in JavaScript because you don't have type information. Everything is very dynamic, very decided at runtime. Once you do have the type information, then you can statically analyze the code and then realize that, oh, these 3 methods are not used. Let's remove them.
How does that kind of, so given that you need to have a lot of this information at build time or compile time, and then you can collect this information, like we said, at runtime, how does this kind of reflect on some of the approaches like Facebook's prepack or something like that? Is that an interesting route to take where we can do some partial evaluation of it at build time?
We're looking into like combining these approaches. We don't have enough experience to know whether this is going to work or how successful it's going to be, but we're definitely looking into like, can we combine different approaches to make these optimizations more powerful.
From an ergonomics point of view for Angular, are you planning, you've mentioned a little bit about the migration path. Like how do you actually go about making it so that the upgrade process is as smooth as possible?
So upgrade is a big challenge for many of the teams that we are working with, especially the ones that have large code bases. We devised several strategies and realized that different strategies work for different teams. So ng upgrade is a library that we offer as a way to cross-link AngularJS and Angular applications at the component level. What we found out is that this works for certain projects, but many of the teams that are upgrading to Angular, they actually want to have a whole section of application that is built just with Angular, not with the legacy AngularJS. So with the ng upgrade approach that we had, it actually created a single application that was using both Angular and AngularJS in a very tightly coupled way. And these teams found it undesirable to have such tight connection. So what they asked for was like, could we actually split the application into 2 sub-applications where one is our AngularJS code base and the other part is just Angular. And when we need to communicate, we will manage the communication between the two at the service level. But at the component level, we don't want to mix Angular and AngularJS components. We're just going to have a whole section of application that is Angular. So because of this, we improved the ng upgrade library to have what we call ng upgrade light option, which allows you to create this whole section of your application to be either in Angular or AngularJS. And this approach has been more successful with large teams. Google Cloud, they're going through big migration right now, and they're using this approach.
Interesting. So is it kind of largely a manual process in the sense of like, here are best practices for upgrading, here are some tools that will give you the best migration path, versus like an automated kind of upgrade path?
There are a few tools that help with automation of the task, but because AngularJS is so dynamic, it's very difficult to statically analyze it. Yeah. And this is the biggest difference between Angular and AngularJS. With Angular, we can statically analyze the code and use tooling to make refactorings. With AngularJS, it's not possible. So our focus is on making the manual work as painless as possible so that teams can move over.
On the implementation side of Angular, kind of diving under the hood a little bit, React kind of popularized this idea of a virtual DOM and whatnot, and it's kind of taken off in a few other frameworks as well, obviously. Can you speak to maybe why you don't adopt this kind of idea or your alternative approach to this, like the trade-offs that maybe that you thought about?
So virtual DOM is the change detection mechanism within React. In Angular, we generate code that checks expressions, and we do the change detection at the model level rather than on the view level. We found this to be more performant, but there are certain trade-offs. There are certain nice properties of having virtual DOM that we're looking into adopting. Maybe in the future, this is a research project we are exploring now.
You mean adopting those features or adopting a virtual DOM?
Adopting the actual solution doesn't matter. Yeah. What we are after is bringing the features in. How it's implemented, whether it's virtual DOM or not, it's not important. Yeah. But we would like to give developers a little more flexibility when it comes to controlling, for example, projection through the components, and there are a few other features that developers that are building highly dynamic applications where the structure of the application is not known at the build time, they're asking for. So we're trying to figure out how to bring these features into Angular.
Makes sense. Maybe one of the benefits that we get from optimizations is that we can have our cake and eat it too, kind of thing, right? I can pull in all of my dependencies and I never really even worry about it because you're going to magically go through and shake the tree and make magic so that I don't have to worry about it.
I showed how it doesn't work yesterday, right?
But is it wrong to think about optimizations in the sense of like, now I get to go to the buffet and eat and I'll never get fat kind of thing?
I don't think it's wrong. It's just you shouldn't. You can rely on it if you also have proof that it works. And this was one of the last points in my presentation is that if you don't measure and monitor what the end result that you're building is, then you might be unpleasantly surprised when your users start using your application. So having the understanding what the user experience is like and how it's changing as you are developing your application and features is important, because that can tell you whether you do need to worry or not. You don't need to worry about these things. You will quickly find out if things work or not.
Yeah, it makes sense. As long as you're measuring it and you're aware of this kind of thing. Yeah. So there's an interesting kind of question about, so you can do these optimizations within a kind of controlled environment, right? If Google Closure, for example, is aware of all the statically type, we can do lots of magic. Mm-hmm. But oftentimes we don't control the dependencies that we bring in. We have the choice not to bring them in, but maybe we're not going to re-implement them. So there's this huge, vast kind of sea of NPM and all these other JavaScript packages out there. How should we think about approaching applying these optimizations to all these dependencies? Like, do we just draw a line and we say, we can't do anything for you over here, we can't do this tree shaking and whatnot?
I think it's all about awareness. I think the libraries that are causing problems for developers and are resulting in poor user experience will fall out of favor if they don't change. The problem we have today, it's not even clear who's causing the problem. You know, you have lots of dependencies, lots of transformations in the build pipeline. So identifying the culprit is very difficult today. But once we do, and once we make it clear that library X and Y does not optimize and prevents other optimizations in the application, then the library either needs to be fixed or we need to find a replacement for the library that doesn't cause the problem, those problems.
Is there some sort of, I don't know, recommendation or guides that you kind of wish that the JavaScript community would adhere to that would enable more of these kind of consistent optimizations?
I think just jumping on the ES modules is the single most important thing everybody can help with. Everybody who ships libraries, there should be an option for shipping ES modules. It's for different libraries, it can be either easy or difficult because we don't want to break the ecosystem. CommonJS is currently used by lots of Node applications. We found a way how we can ship both CommonJS and ES modules in the same package, and this is what we do for all of the Angular libraries. It works because of the style of modularization that we use within the packages. It was much trickier to do it in RxJS, where there are lots of paths from which you import. Each operator can be imported from a new path. And these kind of deeply modularized, as ironic as it sounds, packages are problematic when it comes to shipping both CommonJS and ES module version. So I think what we did in RxJS, we worked with the RxJS team and we implemented a solution where you have to opt in and create this alias for ES modules to be pulled into Webpack. Ideally, you shouldn't need to do anything. The package.json should describe enough, should have enough information for the tools to just do the right thing out of the box. And I think we'll make some changes in the RxJS APIs to make this work out of the box in the next major version.
But summary would be definitely ES modules is the biggest thing that we need to be doing as a JavaScript community.
Yeah.
All right, makes sense. Kind of along those lines, though, you know, there's a spectrum between the optimizations you can do, obviously, statically with limited information. You have kind of incremental things like prepack. You have runtime profile guided optimizations that you can do. Are there any concerns kind of whenever you're dynamically loading these modules? Say, like, you don't necessarily know what you're going to be calling ahead of time, or you're kind of loading them in the browser. Like, what concerns might you have around that?
Version skew. Especially if you have long-running applications, this is something that many people don't think about much until it's too late. If you have applications like Gmail or Calendar that are open for long periods of time, and after the application has been running for a week, somebody clicks on a button and you lazy load code. If you don't have the right version of that code available on the server, because in the meantime you deploy the new version, you will have some unpleasant surprises on the client side. So these are things that we often don't even think about outside of like these huge projects that have sufficient infrastructure to deal with these problems. But I think as we build more and more applications that are sophisticated and running for a long time in the browser, we will need to be dealing with these problems. Service Worker is a nice solution because it allows you to download the whole application in the background and cache it, and that way you don't need to worry about the versioning on the server side. But even there, the service worker needs to be implemented in the right way because you can have multiple tabs open at different time, and you might have different version of the service worker active in these tabs. So
that's an interesting
different
problem.
version of the application open in this tab.
This is quite a unique problem to think about, actually. So Angular Elements was announced recently. I don't know, maybe you can speak a little bit about that, if you have anything that you think is particularly interesting for this audience.
Angular Elements is a way to expose Angular components as custom elements. So if you have an application where you just want to drop in certain components that you built in Angular as a non-Angular application, as just some encapsulated component, then Angular Elements is the solution for that. It's currently in Angular Labs, so we're still gathering feedback and testing in various environments. But it's been very popular, especially for solutions where You have a CMS site that needs to bring in different widgets on a page.
How does that affect things like maybe the bundle size, right? If I'm pulling in all of these Angular elements for a CMS.
So this is one of the things that we are still exploring, because it depends on how sophisticated the component is. Because we have two options basically: either bundle Angular with the component for each component, which is possible, as long as the component is not using a whole lot of features of Angular, because then you have a lot of duplication. The other option is you load Angular once and have all these custom elements shared. The challenge there is, how do we ensure that there is version compatibility between all of these custom elements, because they might have been developed at different times. So these are the things that we're still looking into and gathering feedback from the community and people that are using these solutions.
How about concerns around, for example, performance? If I have multiple versions of these things, and they're all, say, for example, not sharing the same version of Angular, should I be concerned about just having multiple versions of these things running?
Are we talking about runtime performance?
Runtime performance, yes.
It doesn't matter.
Doesn't matter. Very cool. Basically, someone wants to know, do you have anything groundbreaking announcements you want to give us for Angular? Is there anything really cool that you're working on that we should be looking forward to?
Version 5 is almost out. I need to check with the team because we are just working on the very last few things. I think the last RC went out last night. So unless there are any more new problems, 5 should be out. Should be backwards compatible for most of the applications that are using version 4 today. So the upgrade should be super smooth. And we baked in a whole bunch of nice features and size optimizations and stuff like that.
What are you most proud of in terms of the features, or most excited about?
I'm excited about the service worker becoming first-class citizen within the Angular ecosystem. So we're going to be shipping a library that makes it super easy to integrate service worker into your application. And with service worker, we're going to be solving the problem of the network latency, which was yesterday when I was demonstrating the application. I showed like half of this time is spent in network and the other half is JavaScript. Service worker solves that first half of the problem. So that's going to be really cool. It's going to enable offline applications, upgrading in the background, a whole bunch of other stuff.
Are there concerns about managing maybe the complexity? Like as we get more sophisticated tooling and more options, right? We have more power at our disposal. There are more and more things that we actually have to be aware of now, right? We have to be aware of the time it takes to maybe parse tons of JavaScripts, right? Which was not a thing that we really worried about beforehand. Is there some way that you have of maintaining the complexity across all these different concerns inside of an application?
I think the most important thing is that we have the right defaults, which we currently don't, and that's what I showed in my presentation yesterday. Because once you have the right defaults, then many of these things you don't need to think about, they just work. If you need to opt into every best practice, then you need to know about every best practice, even though it's not something you should be concerned about. Like, you shouldn't really be concerned about RxJS being shipped in ES modules, or Babel transpiling your code and feeding into Webpack using ES modules. You should just write your code, and Webpack should pull it in the most efficient way for it to do the optimizations. So I think it's very important that everybody who contributes to the web ecosystem has this in mind and works with everybody else in the ecosystem to get us on the true good default.
Kind of along those lines, so I want to have good defaults, I want to have the ability to measure all these things. Mm-hmm. Is there anything you recommend for kind of automated measuring and monitoring of these applications?
What we did is, in some of the applications that I work on, we integrated Lighthouse into our CA infrastructure. So we run on each pull request and merge, we run Lighthouse tests. That caught a bunch of issues. We also monitor the payload size. We don't use any fancy tools for this. We're just building the application and then storing the current size in a Firebase database. And we break the build if there is an unexpected change in the payload size. So developers either have to fix it, or they have to explain why it cannot, why we have to increase the current budget we have, and justify it.
That's quite an interesting process. It's kind of it's not necessarily an automated thing, but it's baked into the culture of how you actually do this process. You're aware if you're accidentally.
I think
using the size.
because if you don't create this kind of checks, things will just creep in over time, and then it's very difficult to come back and figure out why is our application large. Initially, if you spend a lot of time decreasing the size and understand where the gaps are, or you understand this is the best we can do today, if you say like, if we go anything about this, then we better have a good reason for this, and you have an automated check, then you can enforce it throughout the team.
I really like this idea. Like, I'm not relying on my own discipline to always be aware of this. Rather, I have tools that are like telling me whenever I'm making
It's not
a mistake.
about, you know, the thing is that most of us work on a team with many other people, and I'm not saying that people are not disciplined, but it's hard to be.
I'm certainly not, and so.
I'm trying and failing, but if you have your CI tell you, hey, this is wrong, there's something wrong with your code, it also shows up during code reviews, and that's the best time when you can deal with these issues. So just making it into the process, just like we added tests and automated testing into a development process, adding size monitoring into a process is very good.
So maybe one last question then. There was a question about if I'm an Angular developer, how would you recommend that I kind of improve my skills? Like, how do I actually become the best Angular developer possible?
Why do you want to become the best Angular developer possible?
Well, I want to be effective at my
So I think you
right?
should work on being the best developer possible, rather than best Angular developer possible. Because Angular is just a tool to build applications, and I kind of worry that if people focus just on one technology and become masters of the technology, they often lose out on many other things that are happening outside of the technology. So I think the goal should be know your tool, but also be a good generalist and understand the principles, you know, how things work. Like yesterday, the talk I gave, it was Angular, it was relevant to the Angular community, but it was also relevant to anybody who's not using Angular. And I think it's important to understand these kind of things, like how things work in general, rather than be highly focused on one area.
How do you balance the concerns then of this problem of being a jack of all trades and a master of none? So like I'm familiar with a bit of Haskell and a bit of PHP and a bit of JavaScript, and I can't actually ship anything, right? So isn't it kind of good to go very, very deep in some tools?
I think just having the right balance is the way to go. Understanding how web works, what makes good applications good, even just from the product perspective. You know, this is what many developers are missing. Like, why is this application good from the product perspective? Does it fulfill the user needs? Does it make people happy and productive when they are using it? We often don't understand these things as developers because we are so focused on technology. And then we build solutions that are technologically super advanced, but users that are using it, they're hating it because they can't find the button or whatever, you know, like user problem, that, or we are solving problems that they don't have, right? So looking at the problem from the bigger perspective and understanding what is it that actually helps people, and then finding the right technology and the right approach to implement the solution is the way to go.
Yeah, it sounds quite actionable. Very nice. Thank you very much. Please give it up for Igor.